In figure, if a battery is connected between points A and B, EMF E is equal to 18 volt. If we connect a battery between points A and B, the current flowing through the battery is, we'll have to find the total current flowing through the battery. So before proceeding further, first of all, let me tell you that suppose we are connecting a battery between point A and this is the point B. In that case, some current will be flowing through this, okay, and we'll be distributing this current throughout this circuit. But here you can see that this particular resistance is not a part of any loop. So this is not going to be used in the current distribution because there won't be any current flowing through this resistance, and similar is the case with this. So these two resistances are just useless. Okay, and here it is connected to the earth. The point B is connected to the earth basically. So it don't affect anything because earthing means the potential of the point B is 0. Then potential of the point A will be equal to the EMF of the battery. That means earthing means zero potential difference, zero potential. But by earthing, potential difference between A and B is not going to change. That is going to remain 18. So it also doesn't affect. Here these two resistances are connected in parallel. So what will be the effective value of these two? We know that in parallel we add reciprocals basically. So 1 by R is equal to 1 by 3 plus 1 by 9. So 9 we can take as LCM. So 3 plus 1. So R equivalent becomes 9 divided by 4. Okay, so these two resistances together can be replaced with 9 by 4. So we'll be using it a little later. Now, one important point I'd like to tell you that sometimes when you join these points directly by a straight line, then the form of the circuit becomes simpler. Means, for example, here you can see the point B. Point B is this. E is also the point B. Okay, so this is point B. Alright, and this resistance by the way is not touching this, so don't get confused. So here it is point A. Okay, and this is some other point. So let us assume this point is, suppose E. This particular point is E. E means all these points are E. Okay, and here it is B. E is already there, so let's suppose F. Okay, so here it is point A and then it is followed by the point F at this point, and here it is point B. So first of all, we can see that 18 ohm resistance is connected between F and B. So F and B, there is one resistance of 18 ohm. Okay, so we have considered this resistance. This particular resultant 9 by 4 is connected between these 2 points. One point is E and F, and the other point is here B basically. So this particular resistance, which is 9 by 4, is also connected between these two same points. 9 by 4 is its magnitude. So we have considered these two. Now talk about this 3 ohm. Or first, let's talk about this 4 by 5 omega. It is connected between point A and the point F. So here it is 4 by 5 ohm is the resistance. So we have considered this. Now let's talk about this 3 ohm resistance. One end of the 3 ohm is connected to the point F. It is F basically. So let's correct this. Otherwise, I'll be committing the same mistake again and again. Okay, so here it is point F. So between A and F, it is 4 by 5 omega. And this 3 ohm resistance, one end is connected to the F and the other end is connected to the B. So this particular resistance, 3 ohm, is also being considered. Now the 6 ohm. 6 ohm, one end is connected to the point F, the other one is connected to the point B. Okay, so this resistance is also connected between these two same points. So this is 6 ohm resistance. So here it is point B. And now the battery is connected between these 2 points. So you can see that what I have done, that I have joined all points directly without making any corners or something. So the circuit form has been reduced and it has become much simpler. Now you can see that these four resistances are connected in parallel. So what would be the resultant of these four? Let's say it is R dash, then 1 upon R dash will be 1 upon 18 plus 1 upon this, that means 4 by 9 plus 1 by 3 plus 1 by 6. So here you can see 18 can be taken as LCM, so it becomes 1 plus 2 into 2, 4, 8, and here 3 into 6, 6 into 1, 6, 6 into 3, 3 into 1, 3, then it becomes what? It is equal to 1. As you can see, 6 plus 3, 9, 9 plus 8, 17, and 1, 18, 18 by 18, 1. So R dash is equal to 1 ohm, means all these four together can be replaced with single resistance of 1 ohm value. And now you can see that these two resistances are connected in series with each. So resultant of these two becomes R is equal to 4 by 5 plus 1, which is equal to 9 by 5. So EMF here is given to be 18 volts. So what should be the current flowing in the circuit? So current in the circuit is equal to total EMF divided by equivalent resistance. So EMF is 18 divided by resistance. Resistance value is 9 by 5. So the current is 10 ampere. So option A will be the correct choice for this question.